estimating the mean from small samples. Now question is given. A quality control engineer want to estimate the average tensile strength in MPa of a new metal alloy. A random sample of 9 specimens is tested and the results are 86, 88, 90, 87, 85, 89, 91, 86, 88. Assuming the data is from a normally distributed population, considered a 95% confidence interval for the two main tensile strands. Solution. Step 1. Given data. Sample size n equal to 9. Since n less than 30, we are dealing with a small sample. Population standard deviations is unknown. So, we use the t distribution. Step 2. Calculate sample mean and sample standard deviation. Now you know mean of x. First, you write all data. Then you see how many quantities 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we divide by 9. Depend on quantities, divide by total quantity. Now 790 divided by 9, we get 87.78. Now compute sample standard deviations as use the formula is equal to now square root summation xi minus mean of x whole square divided by n minus 1. We compute squared deviation. Value all is given, you write here according to formula xi minus mean of x, then square 86 minus mean of x, we get minus 1.78. Then this number multiplied by same number and we get 3.17 because here is given square. It means this number multiplied by again this number. Same process 88 minus mean of x, we get 0.22. Then you can see here square, it means 0.22 multiplied by 0.22, we get 0.05. Same process 90 minus the mean of x, we get 2.22. Now he has given square, it means 2.22 multiplied by 2.22, we get 4.93. Same process you follow all steps. Now 91 mean of x minus of mean of x we get 3.22, then square. It means 3.22 multiplied by 3.22 we get 10.37. All steps are same but values are different. Which you apply first step, same process you apply second step, third step, fourth step, and so on. Sum of squared deviation 31.57 is equal to square root 31.57 divided by 8. You get 3.946, then we get square root 1.986. Step 3. Find the t critical value. Degree of freedom df equal to n minus 1 equal to 8. For 95% confidence to tell t 0.025, 8 approximate 2.306. Now we going on step 4. Compute standard error. Standard error equal to S divided by radical n. You know the value of S, we get 1.986 divided by radical n. 9 square root we get 3, then 1.986 divided by 3 we get 0.662. Step 5. Margin of error. ME equal to T multiplied by SE. 2.306 the value of T. This dot shows the multiplications and the value of SE you know 0.662 you write here. After the multiplications of both value we get 1.527. Step 6. Confidence interval. Mean of x plus minus me equal to, now the value of mean of x 87.78 plus minus sign you write here me we get 1.527. Now here is given plus minus sign, it means you can solve this value in first time minus sign and second time plus sign. Final answer. The 95% confidence interval for the mean tensile strength is 86.25, 89.31 MPa. This means we are 95% confident that the true mean tensile strength of the alloy lies between 86.25 MPa and 89.31 MPa. Okay, thank you.